Okay. So we want graphs of AF of x, AF of x minus h, and AF of x minus h plus k, where f of x is the basic reciprocal function. Which function is that?
1 over x.
Somebody?
1 over x.
Yeah, 1 over x, right? You really need to recognize those names. I'll probably tell you what the function is, but you need to know those names. They're classifications of functions. Each of these functions has different characteristics. You want to give it a name. So basic reciprocal function is this. So how do you graph it? Now, one thing that's totally not legal on this test, it's not illegal, I won't penalize it, but I'm not going to give it any credit, is if you make a big long table. Okay? In other words, you can say that AF of x is A times 1 over x, that's A over x, right? And A is, yeah, I didn't say what A was, did I? Okay? So I'm going to have to say what A is. So you might want to write that in on the paper. And if there's a problem like this on the test, it'll have those values. Okay? So let's say A is 2. Then it's going to be 2 over x. Well, you don't write a big long table of 2 over x and graph it and think that you've done a transformation. You haven't. You stretch the graph with arrows, right? And I'm going to do it. Okay? So, well, the f of x function, I'm not even going to draw the points. I mean, I'm not even going to label the axis. You should know what the graph of this thing looks like, which is approximately like this, right? Okay? I'm going to use A equals 1/2, H equals -3, K equals -2. Okay? So, my graph of, here's f of x. I want to construct the graph of 1/2 f of x. How do I do it? Well, there's my graph. I take points. I just mark points in my graph. Okay? And then I have an arrow that represents the y value for this point, right? And an arrow that represents the y value for this point, and an arrow that represents the y for here. And for each of these points, I draw an arrow indicating whose length and orientation give you the value of the function. Okay? I don't have to have numbers. I can just draw the things. Then A is 1/2, so I'm going to do A times f of x. That means every y value is going to be 1/2 of what it was, right? Okay? That means all the y values are going to get halved. So here's a y value, it's going to get halved. The x value doesn't change. For this x, now the y is here, right? And for this x, the y is now here. And for this x, the y is here. For this x, just got a little y. For this x, each of these arrows is half as long, or supposed to represent something that's half as long as before, right? Make sense? Okay? So now I can say, okay, well, I see what's going to happen. It's going to be like this. And that's not a great curve, but it's good enough to convince me that you know how to stretch this thing by a factor of 1/2. Okay? Then, and that's what it means. And if you need to review that video, I'm going to give you a whole list of the videos and draw your attention to the most critical ones. Okay? So you don't have to watch everything to find what you're looking for. Okay, now we want to do AF of x minus h. So, okay, well, right now I've got the graph of AF of X. Now H equals -3. So what's that mean? Means we've got to shift the graph 3 units to the left, right? So I'm going to say shift 3 units in the negative horizontal direction. Now at this point, maybe you at least want to tell me where 1 is. Okay? So you put a scale in this thing and say, okay, x equals 1 here. So if x is 1 here, then that means y is 1 here. You don't have equal scales, but that's okay. That make sense? Because you know the point 1, 1 is on your basic f of x graph. Wherever you put 1 here, the corresponding y value has to be 1, right? So, using that idea, now we see, you know, I didn't want 1 to be too big because I got to move things 3 units to the left, which is going to take some of it off the edge of the board here, right? We'll still see enough. Okay, so I want to move each point 3 units to the left. This is 1, then 3 units is going to be 3 times that long. It's going to be like here, okay? So we move 3 units in this direction. And we move 3 units from here. And we move 3 units from here. And now our curve will look something like this. Make sense? Okay? And then we move this point 3 units to the left. And this point. And then we're cut out of room on the board, so we're just not going to be able to draw the whole thing, but it's going to be something like this, right? It's going to have the same shape as this, but move 3 units to the left. I didn't do a real good job of getting the right shape, that you still understand what I did and how I draw it. And, you know, put a 3 on at least one of these, so I know all these vectors have the same length. Now, why do these vectors all have the same length? Because I'm shifting 3 units to the left. Every point shifts 3 units. Why don't the blue vectors all have the same length?
Half of...
Yeah, each of these is half of the y value, and the y values keep changing, right? So the shorter the orange vector is, and the orange vector represents the y value of the original function, the shorter the blue vector is going to have to be. It's going to have to be half the length, right? Now, if the factor was 2, well, all the blue vectors have to be twice as long as the orange vectors, and that would get us a little bit out of hand there, okay? Which is why I chose 1/2 instead of 2. But you get the idea, and I've done this with other graphs, okay? So if this doesn't get it, you can look at videos of that. I've got videos from last year. I've probably got videos from 1868, okay? I didn't do any videos during the Civil War, though. Okay.
That's Civil War, though.
Huh?
That's post-Civil War, though.
Yeah, I didn't do any during the Civil War. So I got back to 1868 because Civil War ended in 65.
Oh, my.
I remember it well. Okay. Make sense?
Sure is.
Okay, well then all we have to do is the vertical shift, which is shift everything 2 units downward, right? Okay? So all I need is a different color to distinguish. So I'm not going to write out all the words because, you know, I'm trying to get through a lot of stuff. Half the class is almost gone here. I mean, no, you all are here, but half of the time we have for the class. Okay, now, so now I move everything 3 units downward. Now that's quite a ways because 1 is here, right? So on this scale, I've got to move, actually I've only got to move 2, so I'm about right there. K is -2, isn't it? You know, Okay? So I take every point and I just draw vectors of the same length from each point, and I get the general trend, and I didn't move them low enough, but you still get the idea, right? Then you do it more carefully than I'm doing. So all these, oh, I'm doing it to the wrong, I messed it up. I'm trying to do a f of x minus h plus k, right? I want to do it on this one. I want to do it on this one. Okay, so pretend these green things aren't here. Because I really don't have time to fix that, but you know, this is going to come down like here, and this is going to come down like here, and everything gets kind of messed up. But you get the idea, right? And then there's the green thing, and now the whole picture is all screwed up because you can't see anything. I'll get rid of these green things over here. Without messing things up even worse. Okay, get the idea? Three things. Now, when you see a function, you've got to identify what those things are, right? So let's just talk about that real briefly.